Have you created a beautiful Next.js application and are finally ready to show it to the world? Discovering the concepts of DevOps deployments in Linux servers might seem intimidating at first, but what if I told you that I can teach you the skills of deploying your website to DigitalOcean in just about 1 hour? In this course, I will guide you step by step in setting up and configuring a DigitalOcean Droplet running Ubuntu Linux and NGINX, acquiring and configuring a domain for your application, securing your Linux server using best practices, and finally monitoring logs and managing server resources effectively. Ladies and gentlemen, welcome back to the Next.js Deployment course. I'd love to see what you guys have been working on, so feel free to send me links to your projects after they are deployed. Now, let's get to the point. This lesson is here just to provide a more detailed overview of the things that we will cover in the course. First of all, we will need a Next.js project that we are going to deploy. I assume that you already have one, but if you are watching this just to learn the deployment process, that's fine too. For the purposes of the course, I'm going to use a Next.js example project template that they made officially available for everybody to use. Then we are going to jump into DigitalOcean and create a new Ubuntu Linux Droplet. We are going to connect to the server using SSH, which stands for Secure Socket Shell. After we are connected, the first thing that we will want to do is adding a basic firewall to the server. Once we have a server ready, we will also need a domain name for it. I will purchase a domain for the project on namecheap.com, but you can use any other platform such as GoDaddy, Google Domains, HostGator, Bluehost, and so on. Then we are going to configure the DNS records of the domain to connect it to the server. While we wait for the DNS propagation, we can use the chance to install and configure NGINX, and also install the packages required for the Next.js project. After that, we are going to push the Next.js app to GitHub in case you didn't do it yet, but if your project is already in a Git repository, you can skip this step. Then we will clone the Next.js app from GitHub onto the DigitalOcean server. Additionally, we are going to need a process manager to always keep running the project. A tool called PM2 can help us with this. Once that is set up, we can start configuring NGINX as a reverse proxy. This means that NGINX will now be in charge of handling all client requests coming to the server and forwarding them to the Next.js application. After that, we will be ready to enable HTTPS with SSL encryption, ensuring our website is secure. And finally, we will need to obtain the SSL certificates and make sure that they are renewed automatically when they expire. At the end, I will show you an easy way of monitoring logs and also managing server resources. As a final step before starting the deployment process, I want to go over the prerequisites of the course with you. As the course title suggests, this will be a guide for deploying specifically on DigitalOcean. However, it's worth mentioning that the steps used to configure the Linux server are always going to be the same, no matter where the server is located. So theoretically, you could also use this course as a guide for deploying somewhere else, other than DigitalOcean. And the only differences will be the parts in which we use the DigitalOcean dashboard, like the lesson of connecting the domain to the server, for example. As far as the requirements of the course go, they should be fairly simple. First, you are going to need a DigitalOcean account, and since DigitalOcean doesn't offer any servers for free, you are going to need a billing method set up on the account. And then you will also need an account on the platform where you plan on purchasing the domain. In my case, I'm going to be using namecheap.com, but this is just a matter of personal preference. You will also need a GitHub account, but this should really go without saying because you probably already have one. Finally, you will need a Next.js project that you plan to deploy. As mentioned before, if you are watching this just to learn about the process, it's still fine, and you can use the same project as me. For this purpose, I'm going to use one of the example projects that Next.js offers. That's it, the requirements are out of the way and we can finally start. Before we start setting up the server, we actually need a Next.js project for deploying. I assume that most of you are watching this course after you have already completed your project and are ready to publish it. However, if you don't have a project, you can just follow what I'm doing. I could just create a new project, but I want it to resemble a real project and not be empty. For this, I can use the -- example flag while creating the project. I'm going to open a terminal window and navigate to the desktop. Then I'm going to use the npx create next app command along with the -- example flag. And after that, you need to input the name of the example project that you want to use. I'm gonna go with the blog project. Then it's going to ask you for a project name, which I'm going to set to next-demo. It's going to take a couple minutes to download all the files and install the packages. After it's done, I can navigate to the project's directory and use the npm run dev command to start the project locally. Then I'm going to navigate to localhost 3000 in my favorite browser to check it out. Looks like the project has a few pages and most importantly it's running without any errors. Now we can move on to the next step, which is going to be creating the Linux server on DigitalOcean. Open up your favorite browser and navigate to digitalocean.com. You should already have an account with a billing method set up, but if you don't, go ahead and create one right now. After you log in, expand the projects dropdown from the main menu on the left hand side and click on New Project. For the name, I'm going to enter Udemy, but you can choose whatever you want. Description is not required, so I'm going to skip it. And for the purposes dropdown, I'm going to select website or blog, but you can choose whatever best suits your project. I'm going to skip the next step for now. After you are done, you'll be greeted by the DigitalOcean project dashboard with a bunch of different options. We are going to click on Spin up a droplet. For the region, you can choose whatever is closest to you and the potential users of your website. I'm going to select Frankfurt, Germany. After that, scroll down to the operating system section and make sure it's set to Ubuntu with the latest LTS version selected. LTS stands for long-term support, by the way. Then we are going to scroll down to the hardware selection. Again, this is going to be based on the type of the project that you want to deploy. If you build some complex web application, for example, you will probably need more resources. In case you need help choosing the right hardware, DigitalOcean actually created a decent documentation here that can help you. The good thing about it is that you can scale up or down at any moment depending on your needs. All it takes is a server restart. For the purposes of this course, since we are deploying something really simple, I'm going to choose the cheapest option. For the authentication method, let's choose password and make sure you remember it. After you are done, you can check out the summary at the bottom to make sure everything is right. You can also change the name of the droplet if you want. And you can see the monthly price at the bottom. If you are happy with everything, click on Create Droplet. It's going to take a few minutes to initialize. After it's done, you will become the proud owner of an Ubuntu Linux server. And you will be able to see its IP address right here. This time we are going to use SSH to connect to our newly created Linux server. As mentioned before, SSH stands for Secure Socket Shell and is basically a protocol that allows us to communicate with the server securely, even if we are using an unsecured network. In order to get started, copy the server's IP address from DigitalOcean. Then open up your terminal. Use the SSH command, and after that we are going to input which user we are connecting as. We will connect as the root user and then we will separate it with @ and paste the address right here. SSH root @address. The first time you are connecting, it's going to warn you about connecting to an unrecognized server. Just input yes and press enter. It's not going to ask you again for this address. Then input the password that you have chosen when creating the droplet on DigitalOcean. If you don't see anything while typing, don't worry, it's just invisible. Keep typing and when you are done, press enter. Once you see the welcome to Ubuntu message, you have successfully connected, and you might notice that my terminal has now changed to root at Ubuntu, which means it's now remotely inside the server and we can use it to execute commands there. As you are about to see, the first thing that we want to do with the server is set up a basic firewall, because it's very simple and it will help us keep the droplet secure. Use the sudo ufv app list command to show all the available firewall options. By the way, quick fact, sudo is a Linux command that gives us administrator privileges, which are needed for making critical changes. It stands for super user do, so technically the correct pronunciation is sudo, but everybody I know pronounces it as sudo, and I'm gonna do the same, because I like it. Also because it's a male name in Bosnia, actually a great name to call your dog, in case he won't listen to your commands. We are going to allow certain options, and the firewall will simply block all the connections that are not whitelisted. You can see that the only option we have for now is OpenSSH. We are going to use the sudo ufv allow command to allow SSH connections to the server, making sure we can still connect to it from the terminal again once the firewall is up. Then we are going to use the sudo ufv enable command to make the firewall active. Finally, you can check if everything is okay by running the sudo ufv status command. You can see that the firewall status is now active and that it allows SSH connections. We created a server and connected to it. Now it's time to purchase a domain for it. My domain marketplace of choice is namecheap.com. However, you can buy your domain wherever you prefer. Most of these websites are very similar. As part of the requirements video, I mentioned that you are going to need an account on Namecheap, so if you haven't created it yet, go ahead and do that right now. After you have logged in, go back to the home page and search the marketplace for a domain you would like for your project. Let's say that for this project I want a domain that includes NextDemo. You can see that domains with different TLDs can have vastly different prices. For example, nextdemo.io costs $40 per year, but .xyz costs just $1.50. Choose whichever domain you want. I'm going to go with the cheapest one. Once in the cart, I'm going to disable automatic renewal, but you can keep it on if you are going to use the domain for more than a year. Then I'm going to proceed with the checkout. After my purchase is complete, I will navigate to my account dashboard, find the domain I just got and click on Manage. I want to be able to manage this domain through DigitalOcean, and we need to add the DigitalOcean name servers to achieve that. Keep in mind that if you used another platform to buy your domain, the domain management UI might be a little bit different, but in general you'll still be able to find the same options somewhere. In the name servers section, where it says Namecheap Basic DNS, change that to Custom DNS. We will need to add 3 name servers, ns1, ns2 and ns3.digitalocean.com. When you are done, click on Save. With this, we basically finished with Namecheap. Let's go back to DigitalOcean. Now click on the green Create dropdown in the top right corner of the page and select domain/DNS. Enter your domain in the Add Domain section and make sure the right project is selected. Once you hit the Add Domain button, you will be taken to the Domain Records page. We will need to create 2 A records here. For the first one, enter @ in the host name and select the server you want the domain to point to. This is going to be our Ubuntu server from the previous lessons. For the second one, we will do the same thing, except the host name will now be www. It's probably going to take a couple of minutes for these changes to take effect. This is called DNS propagation. While we are waiting for the DNS changes to propagate, we are going to install NGINX on the server. NGINX is an open source web server that can be configured in a lot of different ways. Specifically, we are going to configure it as a reverse proxy, but I will explain what that means a little bit later. You might notice that if you didn't touch the remote terminal for a while, it might become unresponsive. That's because it will time out the connection after a few minutes of nothing happening. You can simply close the tab and connect to the server in a new one if that happens. First, we are going to make sure all the other packages are up to date by running the sudo apt-get update command. Then we can install NGINX with the sudo apt-get install NGINX command. It will tell you which packages are going to get installed and ask you if you want to continue. Simply type Y, which is short for yes, and press enter. When it asks you which services should be restarted, simply press enter. Once NGINX is installed, we are going to adjust the firewall settings again. If you use the sudo ufv app list command, you will notice that now we have NGINX as an option. We are going to allow NGINX HTTP for now, since we don't have HTTPS enabled yet. Use the sudo ufv allow NGINX HTTP command. Make sure you put the name in quotation marks. This will whitelist all traffic coming to port 80 through the firewall, which is basically all HTTP traffic. Again, you can check the firewall status with sudo ufv status and make sure NGINX is allowed. Now we are going to use the systemctl status NGINX command to make sure that NGINX is running, and you can see that it says that it's active right here. Press Ctrl+C twice to exit this. Another way to make sure everything is okay with NGINX is by grabbing the server's IP address from DigitalOcean and pasting it into our browser. If you see the default NGINX page, you are good to go. Another thing that we will need for the Next.js project is the node package. To install it, use the sudo apt-get install node.js command. Again, it's going to ask for your confirmation, simply enter Y and press enter. When it asks you for restarting the services, again press enter. Then install npm with the sudo apt-get install npm command. We will also need to install Ubuntu's build essential package with sudo apt-get install build essential. Make sure that the node and npm packages are installing correctly by using the node-v and npm-v commands. This should output the versions of the installed packages respectively. We are going to push the Next.js project into a GitHub repository in case you haven't done this yet. But if your project is already in a Git repository, you can safely skip this lesson. By the way, it doesn't have to be public, a private repository is fine. Once you are on the home screen, you can create a new repository by clicking the green button in the top left corner of the screen. Enter a name for your project and set the visibility to private, then click create. We are going to grab the HTTPS repository URL, open up a new tab in our terminal and navigate it to the Next.js project. Then we can use the git remote add origin command and paste the copied URL. Now you can simply use the git push command to transfer your changes to the repository. If it complains about the upstream, just copy the command below and paste it into the terminal again. If you refresh your GitHub repository now, your project will be here. The next step will be cloning this project from GitHub into the Linux server. Let's start by connecting to the server using SSH again. If enough time has passed and the DNS settings from before have propagated, you should be able to use the SSH root at whatever domain you got instead of copying the IP address all the time. Actually, this is because whenever you go to a domain, let's say udemy.com, in the background it's being translated to an IP address using DNS. And if you remember, in DigitalOcean we set up the domain to point to the server. So the domain and the server's IP are basically the same thing now. The only reason that we have domains is because it's more comfy telling somebody, hey, check out my new website at udemy.com, instead of, hey, check out my new website at 104.18.106.64. Domains are basically human-friendly IP addresses. Let's get to the point now. Once you are connected to the server, you can see what kind of files we have there by running the ls command. As you can see, it's basically empty. We only have the snap file, which can be completely ignored. Since this is a private repository, somehow we'll need to let GitHub know that it's us trying to clone the repository to a server. Before, we could just log in through the terminal by using the username and password, but now unfortunately GitHub removed support for this, and we need to do it using an SSH key. Let's generate an SSH key pair on the server by using the ssh-keygen command with -t-rsa-b4096. This is a specific key format that is required by GitHub. Press enter to keep the default key location. Press enter again to use it without a passphrase, and once again to confirm. When you are done, navigate to the key's location, which if you are in the home directory is going to be /root/.ssh. If you use the ls command here, you will see that we have two key files, id_rsa and id_rsa.pub. The first one is private and should always be kept only on this machine. The second one is a public key and we want to copy it. We can use the sudo vim id_rsa.pub command to open the file with vim. In case you didn't know, vim is just some sort of text editor for the command line. Then we can just select everything from the file with your cursor and copy it to the clipboard using Ctrl+C. Then you can close vim by typing :q and pressing enter. Then let's go back to the server's home directory by navigating to /home or simply typing cd tilde. Confirm we are back in the home directory by using the ls command again, revealing the lonely snap file. Now with the SSH key on the clipboard, let's go back to GitHub. Click on your profile icon in the top right corner of the page and select settings. Then click on SSH and GPG keys and create a new SSH key. Paste the key we copied from Vim into the key text area and add whatever title you want for it. I'm going to call it nextdemo-server. Once you have added it, make sure it's on the list of authentication keys. Now let's get back to the repository and grab the clone command. Make sure you switch it to SSH before copying. Now go back to the server and use the git clone command followed by pasting the repo link. Type yes to confirm and press enter. If you use the ls command in the home directory now, you will see that the Next.js project was added. Let's navigate inside the folder first. We are going to install the project's required modules by running npm install. Then we are going to run the development version of the project, and if you get an unexpected token error like this, it's probably because your node version is too old. To check it, type node-v. You can see that I have node version 12 installed, but Next.js increased the minimum node version to 16 with the Next.js 13 release. We are going to update to the latest stable version by using npm. Type sudo npm cache clean -f. Then we are going to install the n package globally with sudo npm install -gn. Then we are going to upgrade node with sudo nstable. Now we need to close the SSH session and open up another one. If we check the node version with node-v again, you can see that node has been upgraded to version 18. If we try to run the project in development mode now, we shouldn't be getting errors anymore. Seems like everything is running just fine now. Press Ctrl+C to stop it. Now we are going to use npm run build to bundle the production ready version of the project. The next step would be running the production build of the project just like we ran the development version. However, we need to keep it always running, even when we close this remote session. To achieve that, we are going to install a process manager called pm2. First, go back to your server's command line, navigate to the home directory in case you were in the project directory before, and then we are going to install pm2 globally by running the npm install-g pm2 command. Navigate back to the project folder. To run the application with pm2, use the pm2 start command and the -- name equals to your project name. Then we are going to write which package manager we are using, which is npm in my case. After that, we are going to add just 2 dashes, and finally we are going to add the name of the script we use for running the production version of the project, which is start by default in Next.js. So the final command should look like this. In the table below, you can see that the pm2 process was created and that it's online. Then we are going to use the pm2 startup systemd command, which will make sure that pm2 gets restarted automatically whenever we restart the server. Finally, we are going to use the pm2 save command. In this lesson, we are going to configure NGINX to be used as a reverse proxy. What this means is basically that NGINX is going to intercept each request that's coming to the server on port 80, and after interception, the reverse proxy is going to navigate the incoming requests to the Next.js application instead, which will respond with the HTML and JS needed to display the page to the request sender. To get started, in the server's command line, navigate to /etc/nginx/sites-available, which is the nginx sites folder. We want to delete the default nginx page first. If you use the ls command, you can see that the default site is located here. Let's delete it by using the rm default command. Now navigate to /etc/nginx/sites-enabled and do the same thing here, deleting the default site. Now let's go back to the sites available directory one more time. We are going to create a new site by using the sudo touch command followed by the name of the site, which is going to be exactly the same as the domain you got for your project. In my case, nextdemo.xyz. After that, we are going to open the new file in a text editor similar to Vim. This one is called nano, and it's a little bit more intuitive. Use the sudo nano command followed by the name of the file. Right now the file is empty, so let's start populating it. First, we are going to open up a server block, which kinda looks like a JSON object, but not really. Then we are going to specify on which port it's going to listen to, twice. The first one is for IPv4 connections, and the second one is for IPv6. The next line is going to specify the location where static files are served. After that, we need to specify the default index file, which is going to be index.html followed by all the fallback options. The next line is going to be one of the 2 most important lines of this config. It specifies the domain on which the requests are going to be handled. We need to add one plain domain and the second one with www in front. The next block of configuration specifies how exactly the requests are going to be handled. The first line is the second most important part of the config. It basically means that each request on port 80 coming to the previously specified domain will be redirected to localhost 3000. In this case, localhost represents the Linux server, and if you remember, we are running the Next.js application constantly in the background with pm2 on port 3000. The remaining parts are not so important and we can skip those explanations, basically configurations for caching and sockets. After you are done writing the config file, press Ctrl+X, then press Y to confirm and press Enter to save. Now we are going to create a symbolic link and enable the domain with the configuration we just wrote. Use the sudo ln-s/etc/nginx/sites-available/whatever your domain is. And then the destination will be /etc/nginx/sites-enabled/. To check if everything is okay, navigate to the sites-enabled directory and use the ls command. If you see your site here, the symbolic link was successfully created. Finally, to avoid memory issues in the future, we will want to modify an option in the nginx config. Open a file in nano using the sudo nano command, and the file location is going to be /etc/nginx/nginx.conf. Now scroll down under HTTP and you should see a commented out option called server names hash bucket size. The only thing that you need to change here is uncommented by deleting the hash in front. Press Ctrl+X, press Y and then press Enter. Use the sudo nginx-t command to make sure we didn't make any syntax mistakes in the config accidentally. At the end we will need to restart nginx for the changes to take effect. Use the following command for this: sudo systemctl restart nginx. Congratulations, you are now a proud owner of a reverse proxy server. Now you should be able to navigate to your domain on HTTP and see your Next.js application. In the previous lesson, we managed to get our Next.js project up and running, but it's only using HTTP for now. This makes our website unsecure. If you were using an untrusted Wi-Fi to access it, or you happen to be a target of a man-in-the-middle attack, the attacker would be able to sniff the packets being sent between you and the website, which could potentially reveal all kind of information from you. To stop this, we are going to upgrade the transfer protocol to HTTPS, preventing these shenanigans from happening. Go back to the server's command line and install a package called certbot by using the snap install certbot -- classic command. Then we are going to update all packages by using the sudo apt-get update -y command. After that, we are going to install the nginx certbot by using the sudo apt-get install -y python 3 certbot nginx. After everything is installed, we can modify the firewall settings again. We are going to allow both HTTP and HTTPS requests with the sudo ufv allow nginx full command. We can then get rid of the redundant HTTP rule with sudo ufv delete allow nginx HTTP. After the firewall is configured, we can move on to obtaining the SSL certificate used by HTTPS. We are going to use the new certbot packages to obtain them, and they will also handle renewal automatically when the certificates expire. Use the sudo certbot --nginx -d whatever your domain is -d again www.whatever your domain is command. This will obtain the initial SSL certificates. Enter your email, agree to the terms, and decide whether you are willing to share your email. You can also use the dry run feature to simulate the renewal of expired certificates and make sure everything goes good. For this, use the sudo certbot renew --dry run command. After everything is done, you should now be able to access your Next.js project securely. When it comes to deployment, we are already done. Can you believe how easy that was? After deploying a website, the usual problems that I encounter are things that I missed while developing the Next.js app, or maybe things behaving a little bit differently in the production version. Debugging in production can be really painful and time-consuming. However, having access to live logs of the web app makes it a little bit easier, and it's certainly great to have when you are dealing with pesky bugs that came out of nowhere. In order to access live logging, go back to your server's command line, use the pm2list command to find the ID of your website's process. In my case, the ID is 0. Then use the pm2monit0 command. If you keep this on, whenever an error or warning occurs from the Next.js project, you will be able to see it right here, and easier figure out what's going on. The second common thing that I had to deal with after deployment is making changes to the project. Let's say you change the home page of your Next.js app and you want those changes reflected on the live version. Don't worry, you don't have to clone the project again or anything like that. Simply push your changes to the GitHub repository, and since the server is already connected to your GitHub account with the SSH key, you can simply navigate to the project's directory and use the git pull command to load the latest version to the server. After that, you'll need to use the npm run build command again, and after it's done, you can again find the ID of your process by using the pm2list command. As you already know, for me it's 0, so I will use the pm2 restart 0 command to restart the process and apply the latest build version. Finally, the last problem that I tend to encounter is a lack of server resources. Specifically, I tend to run out of RAM memory, especially if I'm running more than one project on the same droplet, or if I'm working on a complex application. If you want to increase the hardware power of your server, you need to do it from DigitalOcean. Open your project's dashboard page, click on the droplet, select power and then turn the server off, as you cannot make any hardware changes while it's running. Then click on resize. Here you can adjust your hardware resources according to your needs. I usually end up increasing it one step at a time and checking the results in action until I'm happy.